Good morning, friends. Our next unit and next source is the miscellaneous sources of renewable energy, and one of that source is the tidal energy. So, we will today start with the tidal energy, and majority of us have learned about the tidal power or tides in the school days. Am I right? So what we learned at that time, let's recapitulate the same. So how does tide occurs? So usually it's a gravitation. Obviously it's a gravitation, but there is a gravitation pull of the moon because moon is nearer compared to the sun. So if it is the theory and we can assume that it is correct, then the earth and the moon, then due to gravitational pull of the moon, the earth motion will experience a bulge at a particular side where moon is existing. So anybody at this point where the bulge of the water will towards the moon, there might be an experience of high tide. But it has been slightly modified. As the earth rotates around its own axis, there will be one tide per day, but there are actually two tides per day. Usually, if you can consider a lunar day with comprising of 24 hours and 50 minutes, so there could be two high tides and two low tides, considering roughly 12 hours and 24 minutes for high tides. Usually it is 12 hours and 25 minutes as a whole. And for second 12 hour and 25 minutes there will be a low tide. So there will be high tide and low tide due to gravitational pull of the moon. So this could be the tidal time. So the level of the water in large ocean of the earth rises and falls according to the predictable terms. The main period during a diurnal, that is during a day, and we can consider the semi-diurnal, that is a half day. So there could be an excessive way of high tide and there could be a successive way for the low tide. So the change in the height between high and low tide known as the tidal range R. This varies between about 0.5 meter in general and about 10 meter for particular site near continental and landmass. So the movement of the water produces tidal current which reach speed of 5 meter per second approximate in the coastal regions and inter-island channels. So if you can consider the lunar day, during one lunar day, if you can considering particular 4 tides per day, that is 2 high tide and 2 low tide. The time between consecutive low tide and high tide is 6.207 hours. Specifically, the daily variation in tide level is mainly due to the changing position of the moon. I can consider one of the application not related with the tidal but related with the position of the moon. You may find lots of videos and literature on the horoscope. They are basically depending upon the moon sign. Usually the position of the moon also affect this horoscopic concept. But over here we are considering the tidal. I just want to recollect where we have heard this kind of particular words of changing position of the moon. That is what the point. So in this session I will try to cover only introductory aspect of the tidal. In the later section of another lecture we will consider how the tidal power plant is existing and how we can harness the electrical energy from the tidal power plant. So as we have seen that we have a 2 tides per day, 2 high and 2 low, comprising of 4 tides per day. So there will be another tides known as the monthly tide. This we are talking about the daily tide. So if we can have a datum level, there could be a tidal period, means the power generating is on, and over here also power generating is on. So if we can think about using the bidirectional turbine, so we are having the mixed tide type, particularly height of the datum level, and for diurnal tide, for daily tide, this is the tidal period, consecutive time between two high tides. So how the actual process with the sea could be occur? So as we have seen that from the gravitational pull of the moon, the surface water is pulled away from the earth on the side facing of the moon, and at the same time solid earth is pulled away from the water on the opposite side, that is from poles to equator. Similarly, thus tides are occurring in this area and relative position of the moon changes, and so do the tides. So there are thus periodic succession of high and low tide. At the time near full moon, so it is an impact of the monthly variation in the tide, where sun, moon and earth are approximately in line. So the gravitational pull enhances in this particular segment in context with the moon, and we experience the high tide. Talking about the daily tide variation, if we can incorporate the moon position at the same time, this is what the high tide and high tide means consecutive time period 12 hours 25 minutes. In that case we are experiencing one high tide and one low tide. Similarly, the tidal range is important concept, is exceptionally large, where high tides are higher and low tides are lower than the average. High tides are also known as spring tide. On the other hand, near first and third quarter of the moon, sun and moon right angles to each other, there could be a neap tide. So that is a concept as compared to position of the moon from new moon to full moon. There could be a first quarter and third quarter. It could be a third quarter, it could be a first quarter, it could be intermediate point, and according to the position, the spring and neap tide is occurring. So this diagram shows the tidal variation in a particular month from new moon to new moon. So from new moon we'll start with the spring tide, then we have a part session, the neap tide, then at full moon, then we have a highest peak of the spring tide. You can take any of the day where you are experiencing too high and too low tide. But this is the diagram or a graph for monthly tidal layers and the tidal ranges. So from this sketch downloaded from the internet, you will be able to know that how the spring tides are working. And this is what the gravitational pull of the earth due to moon. As the mass of the moon is very small compared to sun, but as the moon is nearer to the earth, in that case the gravitational pull of the moon is a main contributor for the generation of the tides. See, from GIF you will able to observe that how there could be a contribution of lunar and solar tides in the impact of the earth. This is what the variation with the change in position of the moon. This is what we call as a tidal range. We have a flood current, we have a ebb current, that is high tide and low tide, the lowest point of low tide and the highest point of high tide. Talking about the monthly variation, that is spring and neap. With the help of this GIF, you may able to know this, how the tides are going to be changed considering spring and neap tide. So, up to this point, we have considered the high tide and the low tide. Usually 4 tides per day, and these are the monthly variations in the tide. So in the particular day, you can consider any date or a number which comprising of a date from 1 to 31st of any month. There will be 4 tides per day, and it could be in the range of spring or neap tide. Accordingly, the tidal range of the ocean may vary. So this is how the another GIF, the gravitational pull of the moon, that could be impacted on spring and neap tide in very simplistic manner. So again the cycle will complete and the next cycle will start. So again there will be a neap tide, again there will be a spring tide. And now the cycle will about to end. It is also known as waxing crescent. From the first quarter, gibbous, then again full moon, then waning, and again waning crescent. So these are the modifications in the intermediate point of the moon that was not shown in the previous GIF files. This is the basic understanding of the tide. Talking about the spring and neap tide in simplistic way, these are the intermediate points. These are the points where the spring tide will about to start. Talking about the potential or tidal range. So considering the reservoir, the concept is very simple. If you can enter this water into the dam kind of structure, is known as the basin, and ultimately when we open this gate, at that time the water will fill, and if it is the bidirectional or a bulb turbine, it will be rotated in the same direction. During the low tide time, due to gravitational pull of the moon, again this basin will empty, and again the turbine will rotate into the reverse direction. Talking about the equation of the potential energy of this layer, we are having E equals to mgh. M is rho a, g is the gravitational constant, and h is the height of the dam, and dm is the mass of the water. We are integrating with respect to tidal range. We are getting the potential energy E equals to half rho a g r square. This is the equation of the tidal range, where rho is the density of the water. So with this we can have a close look with one particular example, where from the tidal power reservoir we need to find out how much power that they are going to produce. See, compared to conventional power plant, the word estimated power is used in certain renewable energy sources. So let's begin the numerical. It says that a tidal power plant has a reservoir of area 50 into 10 raised to 6 meter square. The tide has tidal range of 10 meter. The turbine can operational with the head of 3 meter or more. So after 3 meter it will start generating. So my tidal range is integration of certain height for 10 is the upper limit and 3 is the lower limit. Considering the efficiency of the turbine is 80%, so we need to estimate the total power generated in one filling of employing cycle. So before starting with the solution, there might be a different scheme that I will try to cover in the upcoming session, that is in terms of single basin scheme, double basin scheme, single basin, double basin with linked scheme. We have an extra storage facility that is available. Lots of other scheme will be there that I will try to cover in the next session. But in this point, how the employing cycle will work, that is the main consideration of this numerical. So if you have an equation of A, that is rho Ag integration of lowest meter, that is 3, and highest meter, that is 10, for we need to go for HDH. So we have half rho Ga 10 square minus, this is the highest height and this is the lowest height, it is equals to 91 by 2 rho Ga. Now power equals to energy per unit time, so it is E by T. Now we are considering roughly 6 hours and 12.5 minutes time, that is 22,350 seconds over here, because we need to consider one filling period. So 24 hours and 50 minutes are divided by 4, so it is 6 hours and 12.5 minutes. So the equation will be power E is 91.2, rho is the density of the water, we are considering G 9.81, A area 50 into 10 raised to 6 is given, and the rho usually 1000, but for the saline water it is more than the 1000. So the power production is approximately 1 megawatt during this filling time, and then we can harness the power from the tidal and it has been fed to the nearest substation. Now talking about the dominating force on the tidal power, means how the moon has a more gravitational pull compared to sun mathematically. So if you can begin with mass of the sun and mass of the moon, the distance from the earth to sun, that is ds, the distance from earth to moon, that is dm, and the gravitational pull is g. Now if we can talk about the force from sun and moon, and that forces are implying onto the earth, so Fs is g, me, this me is the mass of earth, ms is the mass of sun divided by ds square. Similarly Fm, that is force due to moon on the earth, if you take the ratio, if you can put the constant which is available, the force of the sun is higher compared to force of the moon, but due to gravitational pull the force of the moon is dominating. This is how during week time the spring and neap tide is going to be occur. So at that time the figure shows the systematic layout of spring tides and neap tides. So whenever we are considering this spring and neap tide, at that time our position of the moon and sun is fixed, so position of the moon is going to be changed, and we can having this tidal power generation in terms of spring and neap tides. Talking about India, you may find these Sundarbans, and at the Bangladesh also, at the Bay of Bengal, you will able to find certain tidal power generation at that time. This is one more tidal power site at the Bay of Kutch, and over here we are having the Arabian Sea. There might be a futuristic projection of the tidal power plant, because over here we will get the high head where we can have a Gulf of Compact, and we can have the tidal power generation from this. There is one project known as Kaya Gulf project. In the same case, we have considered the upcoming power project, and these are the various specifications of the same. It includes 12 rivers. For Gujarat, we have a Dahar, Sabarmati, Mahi, Narmada. We have a 65 kilometers approximate long dam and 35 meter wide. the tidal power plant of approximately 5900 megawatt by installing the bulb turbines 40 megawatt each in a row. Similarly, we are having the highway multi-lane and railway crossing lines for the same. There might be a Ghogha in Bhavnagar district, Saurashtra, and Haswar in Bharuch district. By reducing the distance, if you can add it up by 225 kilometers. So we have a reclamation of the land of 4 lakh hectares of the saline will be replaced by the fresh water. In the modified plant, the investigations are redoing for 29 kilometers and the estimated costs are varying between 5,000 to 30,000 crore. It might be completed at the end of this year. This is what the data we can have from the internet resources. So there are certain terms and definitions related with the tidal power plant. So the first is what we call as a amplitude. It is a synonym of the tidal range, means how much higher tide that could be there. There might be a bay. The bay is a recess in the Shire, an inlet of the sea between two caps, and inlet of the sea between two headlands. It is a bay. Usually we are using this word, Bay of Bengal, etc. The third is the backwater effect. You have seen this backwater effect number of times in our day-to-day life. Usually during the high tide there will be a backwater effect is less. During low tide the sea water will create the backwater effect. If you are traveling on the particular bridge which is in the bottom side of the bridge, there will be a big water resources or reservoir on which you may see this backwater effect. The next is the barrage, is nothing but the dam which can have a lesser height compared to our actual dam. Then we have a bulb turbine. It's ogive shaped axial flow turbine that can work as a turbine and or a pump. It might be a bidirectional if you want to generate the power for all 24 hours, means entire day. Change in tide, that is change in mode of tide, high tide and low tide. Then we have crest, that is highest level of the high tide. Then we have a delta, it is known as depositional area near the river mouth where sediments are deposited and we will allow the fresh water into the basin. Then diurnal, that is daily recurring within the 24 hours. Then we have a diurnal range, that is amount of variation between maxima and minima. Then we have a double effect. In the reversible type of the scheme, the power is generated into the two ways. That is known as the double effect. When we will discuss about the tidal range in the upcoming session, I will try to explain in detail what is the meaning of double effect in that case. Then we have a ebb tide, the tide associated with decreasing level of the water known as ebb tide. The next concept is estuary, a part of a river or a stream which is influenced by the tide in the main sea or the ocean. It might be a mouth of river where river current meets the tidal current. We will be able to observe certain rivers that could be merged with the ocean. You may find this merging of estuary in Gujarat nearby Dwarka, where the Gomti river meets the Arabian Sea. Then we have a sluice way, that is passage way or artificial way to inlet water through. And then we have a upswelling, that is rise of water or rising of water. This is what the concept of tide. During high tide, if it is the single direction, then this turbine generator set is off, the basin will be filled and the gate will close. During the low tide, the forcefully water could be drained from tidal to basin. This is the single way generation. In the double way generation, that turbine generator set, particularly turbine, will be a bulb type, so the direction of the rotation of the generator remains same, but the way of the input of water flow will be from the different side, so the direction of the turbine will be changed. We are having the double power generation. So that is how the turbine generator unit will be works. This is the ocean side over here, and this is the basin side. This is the typical lookout of the single basin tidal scheme. We are having the open water on the ocean, we are having the closed basin, then we are having the sluice, that is gate, the barrage, and we have gated turbine. Similarly, we have a single basin arrangement. We are having the sea and the basin. In the first case, the power is producing. If it is the two-way turbine, there could be a power is also producing from this fashion. And if you can see that this is a filling and emptying of the basin. This is also another topology, that is double basin scheme. So we can fill this upper basin first, and through this linked basin scheme, double basin scheme particularly, the lower basin will filled forcefully due to natural force, but the generators are connected between the interconnection of upper and lower basin, known as the double basin scheme. There might be a solution that you may produce two turbines over here, but at that time the area of the basin is different, so it might happen that either of the basin will remain empty or could be filled, particularly during the daytime or a night time, depending upon the spring and neap. So in that case, this is the most appropriate construction by using the double basin. I could try to repeat that. If we are having the double basin scheme, there might be an option that people are thinking have a incorporation of TG set over here and TG set over here also, and keeping them bidirectional. But in that case, if you can maintain this both of the area constant, otherwise there could be a lapse of overlapping of the generation time, or it might be a no generation time for the particular basin. These are some pics of the tidal power generation, and this is the peak of the wave power generation. This is upcoming renewable technology. So in this session, I tried to cover the basic concept of tide and the topology of the basin scheme. In upcoming session, I will try to cover how the basin will fill and which mathematical curve it should operate with some fundamental logics. Now, in our day-to-day life, we are using solar power and wind power predominantly, but these are the new upcoming renewable energy technologies. So the thing is that how it is look like, we have taken an example of Kayak project. Over here number of turbines will be connected, and you will get a good power generation of the same. This is the GIF of the incoming tide and outgoing tide for the sake of the better understanding. So with this, thank you very much for having this close look of the first session of the tidal power, and I hope that you will get something new from this lecture in the field of renewable energy technology and the tidal power. So if we can recap the things in this session, I tried to cover the basic of tides, how the gravitational pull of the moon is most dominating compared to gravitational pull of the sun, though the force of the sun is more compared to force of the moon, how the tidal powers are generated, what are the various topologies of tidal power, with certain practical examples of tidal range. With this, I am going to conclude the session. Thank you very much. Thanks for your time, for patience hearing. Thank you.